In today's video, you're going to see 5 rocks that you can break to find diamonds and other precious stones like rubies and emeralds inside them. These rocks are known as host rocks, and if you know how to identify them, it might be that when you open them, you'll find some of these treasures that can be worth anywhere from hundreds to thousands of dollars, depending on the stone you find. For example, what you're seeing right now on your screen is a piece of kimberlite with a diamond stuck in it. Of course, most people would never imagine that this rock had a diamond like this inside it. But when you break this rock the right way, in the right place, what's inside it can change your life. And the most impressive part is that if you know how to identify these rocks, you'll see that many of them are within reach of anyone who knows what to look for.
Oh my God, oh my God.
And that often they don't even need to be broken to access what's inside, because erosion has already done that. There are 5 specific types of rock that, when found in the correct geological environments, can hide diamonds, sapphires, garnets, tourmalines, and other gems of high commercial value. The problem is that most people don't know how to recognize these rocks. They walk right past them, think it's just old rock, and miss the chance to find something valuable that was literally under their feet. That's why, in today's video, you're going to learn exactly what these 5 rocks are, how to identify them in the field, what type of gem each one can hide, and most importantly, how to break them safely and efficiently to expose what's inside. Because there's no point knowing that the rock has potential if you don't know how to access the material without destroying it or hurting yourself in the process. Of course, not every rock is going to have a gem inside. In fact, most of them won't have anything. And that's why you need to read the right signs, recognize textures, colors, mineral associations, and geological context so you don't waste time. After all, even if you break 5, 10 rocks without finding anything, just one quality gem is enough to make up for all the effort. So stick with me until the end, because you're going to leave here knowing exactly what to look for, where to look for it, and how to turn an ordinary rock into a discovery that can completely change the way you see the ground you walk on. The first rock you need to know is kimberlite. And if there's one stone on this entire list that deserves your full attention, it's this one. Kimberlite is a rare type of volcanic rock that originates more than 90 miles deep inside the earth, in the upper mantle, where temperatures and pressures are so extreme that carbon crystallizes into diamond. When a kimberlite eruption occurs, which is an exceptionally rare event, it violently shoots upward through the crust, carrying with it fragments of mantle rock and any diamonds that form there. That means kimberlite doesn't create diamonds, it transports them. And that's exactly why finding kimberlite in the field can be a strong indicator that diamonds might be present. In its fresh form, kimberlite is a dark greenish-gray rock with a fine-grained matrix, often containing visible crystals of olivine, pyrope garnet, and other mantle minerals. Over time, exposure to weathering turns it into a softer, yellowish or reddish material that's easier to break apart. In some cases, kimberlite bodies are so weathered that they look like clay or compacted dirt, which is why many prospectors walk right past them without realizing what they're looking at. But if you know the signs, you can spot kimberlite even in its altered state. One of the most reliable field indicators is the presence of pyrope garnet, a deep red to purplish red mineral that forms under the same high-pressure conditions as diamond. If you find small, rounded garnet grains scattered on the surface or mixed into the soil, especially in areas with a history of volcanic activity, that's a strong signal that kimberlite might be nearby. Other indicator minerals include chrome diopside, which is a bright green pyroxene, and ilmenite, a black metallic oxide that often appears as small, shiny grains in heavy mineral concentrates. When you start seeing these minerals together, you're likely dealing with material that came from deep in the mantle. Breaking kimberlite requires a different approach than breaking most other rocks. Because it's often soft and crumbly, especially in weathered zones, you don't need heavy hammers or chisels. A small rock pick and a sturdy bucket are usually enough. The goal is to break the rock into manageable chunks and carefully inspect each piece for indicator minerals, or, in rare cases, small diamond crystals. Diamonds in kimberlite are usually octahedral in shape, with a greasy or resinous luster that stands out from the duller matrix. They're also much harder than any other mineral in the rock, so if you find a clear or slightly yellowish crystal that scratches glass with ease, you might be holding something extremely valuable. In the United States, kimberlite occurrences are known in states like Colorado, Wyoming, and Montana, though most of these deposits don't contain gem-quality diamonds in commercial quantities. Still, even finding indicator minerals in these areas is significant because it confirms the presence of deep mantle material and opens the door to further exploration. In other parts of the world like South Africa, Russia, and Canada, kimberlite pipes have produced some of the largest and most valuable diamond deposits ever discovered. And the process of finding them always starts the same way, by recognizing the rock, understanding its context, and knowing what to look for inside. Now, pegmatite is probably the easiest to recognize in the field. Pegmatite is an igneous rock that forms during the final stages of granite crystallization when the remaining magma is extremely rich in water and dissolved elements like lithium, boron, and fluorine. Because of this high water content, crystals have more time and space to grow, which is why pegmatites are famous for their unusually large mineral grains. In a typical pegmatite, you can see quartz crystals the size of your fist, feldspar blocks as big as bricks, and sheets of mica that peel off in layers several inches wide. But what makes pegmatite truly valuable is that it's also the primary host rock for gemstones like tourmaline, beryl, and topaz. Tourmaline appears in pegmatites as long, striated columns that range in color from jet black to deep green, pink, blue, and even multicolor combinations known as watermelon tourmaline. The crystals grow perpendicular to the host rock and often stand out visually because of their darker color and strong linear striations running along the length of the prism. In some pegmatites, especially those with pockets or vugs, you can find well-formed tourmaline crystals that are completely free of matrix, making them ideal for cutting or polishing. And even if the crystal is still embedded in the rock, a careful break along the natural fracture lines can free it without causing damage. Beryl is another major gemstone found in pegmatites, and it includes several well-known varieties like aquamarine, emerald, morganite, and golden beryl. In pegmatite, beryl typically forms as hexagonal columns with smooth faces and a glassy luster. Aquamarine, which is pale blue to blue-green, is the most common variety found in pegmatites across the United States, especially in regions like Colorado, California, and New Hampshire. The crystals can range from tiny fragments to massive columns weighing several pounds, and even lower-grade material has value in the collector market. Emerald, which is the green variety of beryl colored by chromium or vanadium, is much rarer and usually forms in specialized pegmatites associated with metamorphic rocks. Topaz is the third major gemstone associated with pegmatites, and it's one of the hardest minerals you'll encounter in the field, with a Mohs hardness of 8. Topaz crystals are typically colorless, pale yellow, or light blue, with sharp, well-defined faces and a strong vitreous luster. They form in the late stages of pegmatite crystallization and are often found in cavities lined with quartz and muscovite mica. Because topaz is so hard and brittle, breaking it out of the host rock requires precision. The best approach is to use a small chisel and carefully work around the crystal, following the natural cleavage planes of the surrounding minerals. If you try to force it, the crystal can shatter along its perfect basal cleavage, leaving you with worthless fragments instead of a cuttable gem. In the field, recognizing pegmatite is straightforward. Look for light-colored rock outcrops with very coarse texture, often appearing as veins or dikes cutting through darker metamorphic or igneous rocks. In road cuts, pegmatites stand out because of their large, blocky crystals and pale color, which contrast sharply with the surrounding material. Once you've identified a pegmatite body, the next step is to examine the weathered surface and the loose material at the base of the outcrop. Many gemstone crystals are already partially freed by natural erosion, and with minimal effort, you can extract them from the soft, decomposed matrix. And if you find one tourmaline or beryl crystal, there's a good chance that more are nearby, because pegmatites tend to form gem-rich zones rather than isolated occurrences. The third rock on the list is marble, a metamorphic rock formed when limestone is subjected to high heat and pressure. Pure marble is white and composed almost entirely of calcite, but most natural marbles contain impurities that give them color and, more importantly, create the conditions for gemstone formation. When marble comes into contact with igneous intrusions or hydrothermal fluids, a process called metasomatism occurs, where new minerals crystallize in response to chemical changes in the rock. This is how corundum, which includes ruby and sapphire, forms in marble. In aluminum-rich marbles, especially those exposed to high temperatures, corundum crystals grow as hexagonal prisms or barrel-shaped grains. Ruby, which is red corundum colored by chromium, is the most valuable variety, but blue, pink, and even black sapphires can also form in the same environments. Breaking marble to find corundum requires patience and a good understanding of the rock structure. Marble is moderately soft, with a hardness of 3 on the Mohs scale, so it breaks easily with a hammer. The challenge is identifying which layers or zones are most likely to contain gemstones. Look for sections of the marble that show color banding, especially zones with a pinkish, grayish, or bluish tint, as these often indicate the presence of corundum or spinel. Once you've located a promising zone, use a chisel to carefully break the rock along its natural bedding planes. Corundum crystals are much harder than the surrounding marble, so they'll resist scratching and stand out visually as solid, well-formed grains. Even if the crystals are small or heavily included, they're still valuable as mineral specimens or as raw material for lapidary work. Schist is a medium to high-grade metamorphic rock characterized by its foliated structure and high mica content. Schist forms when shale or mudstone is subjected to intense heat and pressure, causing the minerals to recrystallize into aligned sheets. This alignment gives schist its characteristic sparkle, which comes from countless tiny mica flakes reflecting light. But beyond mica, schist often contains valuable accessory minerals like garnet, kyanite, and staurolite. Garnet is by far the most common gemstone found in schist, appearing as dark red, wine-colored, or brown crystals that range from pea-sized grains to fist-sized specimens. In some schists, especially those derived from aluminum-rich protoliths, kyanite forms as blue and bladed crystals with a vitreous luster and perfect cleavage. Breaking schist to extract garnets is relatively simple because the rock splits easily along its foliation planes. Use a flat chisel and a light hammer to pry apart the layers, exposing the internal structure. Garnets often weather out naturally and can be found loose in the soil at the base of schist outcrops, but the best quality crystals are usually still embedded in the host rock. Once you've exposed a garnet-bearing layer, carefully work around the crystal using the tip of the chisel, taking advantage of the schist's natural weakness. With minimal effort, you can pop the garnet free without damaging it. And if you find one garnet, keep breaking more layers, because garnets and schist tend to occur in clusters rather than as isolated grains. Now we get to basalt, a dark, fine-grained volcanic rock that forms from rapidly cooled lava. Basalt itself isn't particularly valuable, but it's the host rock for some of the most beautiful and sought-after gemstones in the world, including amethyst, agate, and peridot. These gemstones form in gas cavities, also called vesicles, that were trapped in the lava as it cooled. Over time, mineral-rich groundwater seeps into these cavities and deposits layers of silica, forming agate and chalcedony. In some cases, the silica crystallizes into quartz, which can be colorless, smoky, or, in the presence of iron impurities, deep purple amethyst. Peridot, which is a gem-quality variety of olivine, forms directly in the basalt matrix and appears as small, olive-green crystals with a glassy luster. Breaking basalt to find geodes and gemstones requires a different technique than the other rocks on this list. Basalt is hard and dense, so you'll need a heavy hammer and safety glasses. The goal is to look for rounded, hollow-sounding nodules or sections of the rock with visible cavities. When you tap on a basalt geode with a hammer, it often sounds different from solid rock, producing a slightly hollow or ringing tone. Once you've identified a promising nodule, place it on a stable surface and strike it firmly along its equator, not directly on top. This helps split the geode cleanly in half, exposing the internal crystals without shattering them. And even if you don't find a perfect amethyst geode, smaller agate nodules and chalcedony-filled cavities are still valuable and widely collected. In other words, finding gems in nature is not a matter of luck, but of applied knowledge. Each of these rocks has a different geological formation, and each of them hides specific crystals. The difference between walking right past and making a valuable discovery lies in knowing how to read the signs, recognize textures, understand geological context, and, most importantly, having the courage to break the right rock at the right time. Now let's suppose that during a trail hike, you pass by a road cut or explore a gravel area near a river. You see a rock with coarse texture, opaque. It looks like a crystalline fragment. Would this be a quartz, topaz, or something more special like a ruby or diamond? Well, to know that you can perform hardness, density, and refraction tests to be sure of what you found. And that's exactly why we created the book Gemology Journey for Beginners, available now on Amazon. It was written specifically for people who want to learn how to identify precious stones with simple, practical, and accessible tests that can be done at home without professional equipment. Inside the book, you'll find detailed explanations about hardness, density, luster, cleavage, and all the physical characteristics that differentiate a valuable gem from a common stone. It's like having a complete field guide always at hand, ready to be consulted every time you find something that seems special. But if now is not the right time for you to get the book, no problem. You can still keep learning all of this for free here on the channel by subscribing and watching the next video that's appearing on your screen right now. Each episode was created to help you see what others ignore, and who knows, make your own discovery someday. Thanks for liking and subscribing. Good luck, Gem Hunter.